Good morning and welcome to the first of our two round tables for HQ-5. This round table will be dedicated to the historiography of physics. And it is the first of two round tables. The second will take place Thursday. I want to start thanking very much the organizers and the sponsors, all the sponsors of this conference, and our four panelists for accepting our invitation. And also I'd like to send a special thank you to my co-organizer of the roundtables, Alex Bloom, who unfortunately couldn't be with us here in Salvador. So this morning we are having a conversation about the existing historiography of quantum physics, looking back at the work that has been done so far, mainly but not only in the last couple of decades since the beginning of the HQ conferences. The idea is to chart the ground that has been covered so far as a basis for then exploring possible directions of further development, which will be the main theme of the second roundtable. The format of the roundtable will be as follows, and the purpose is just to ensure that every participant gets enough time, that there is genuine discussion, and that discussion is focused and productive. So after my brief opening remarks, there will be opening inputs from each of the panelists. The length will be from 5 to 8 minutes, and then there will be, if the panelists wish, their follow-up intervention after all the initial inputs have been provided. This will be followed by a coordinated discussion among the panelists, about 20 to 30 minutes, and then we will open the floor to questions from the audience for the remaining time. All right? So Alex and I shared with the panelists 3 guiding questions. These questions are meant to serve as common foci for the discussion, but not to limit the discussion. So please, panelists and audience, feel free to suggest modifications and additions to raise new questions, new topics. The questions that we proposed are the following. First question, in your view, what themes or approaches have shaped the historiography of quantum physics over the past decades, and what developments or turning points have been particularly important? Second question, what conceptual tools, sources, or perspectives have enriched the field, and what might be underexplored or missing? Third question, to what extent has the history of quantum physics developed into a distinct research field? And what do you see as the crucial institutional conditions that can secure the future development of this field? So let me now introduce the panelists. I will introduce them strictly in alphabetical order, even though the order of the intervention will be different. Is there a Brazilian alphabetical order? No, this is the Italian alphabetical order. Sorry, I don't know about the Brazilian one. All right, so we'll begin. You'll explain me later. I will begin with Elise Crew, who studied physics and philosophy and named and earned a PhD in history and philosophy of science from the University of Notre Dame. And she held a postdoctoral fellowship at the University of Aberdeen and another at the Hebrew University of Jerusalem, and she's currently Associate Professor of Philosophy at City College of New York and CUNY Graduate Center. She conducts research on the historical and philosophical foundations of quantum mechanics and metaphysics, the metaphysics of physics, right, I suppose. Thiago Hartz. He's an assistant professor in the mathematics department at the Federal University of Rio de Janeiro, where he also serves as a vice head of the graduate program in teaching and history of mathematics and physics. He wrote his PhD here at the Federal University of Bahia under Professor Olival Freire. with a focus on the history of quantum field theory. He was a postdoc at the Niels Bohr Archive in Copenhagen and a researcher at the Museum of Astronomy in Rio de Janeiro. And Alexei Kojevnikov studied physics at Moscow State University before earning his PhD on the early history of relativistic quantum theory. After a series of international postdoctoral positions, he taught history of science at the University of Georgia, and since 2006 has been with the Department of History at the University of British Columbia in Vancouver. And last but not least, Jean-Philippe Martinet earned his PhD dedicated to Vladimir Fock in 2017 from the University of Paris Diderot. He's currently a postdoctoral researcher at the Max Planck Institute for Gravitational Physics in Potsdam, working on the history and philosophy of the two-body problem in general relativity. All right, let's get started. And the order of interventions will be Alexei, Thiago, Elise, and Jean-Philippe.
Okay, does it work? The microphone? Okay, yeah. I asked to go first because I claimed age seniority, yes. And because in some sense I feel that I have the oldest disciplinary memory in the field. And I also asked or chose that I actually talk not about the last 20 years, at least in my first intervention, but about the early period of quantum historiography and how the discipline was formed. And I start with the 1960s. Because before 1960s, there was some important work on history of quantum, even by philosophers and historians, but still the field was largely dominated by physicists' own accounts. Their own myth, they kind of, the participants' account, so to say, they kind of, they wanted to popularize the field and also popularize their own myths within the discipline. But in 1960s, there was a certain revolt by historians against the physics-dominated field, and the crucial sort of, it happened in different countries, but the most important kind of event happened around the project of the Archive for History of Quantum Physics in the United States. Could you please turn on the first slide? I'll go over slides very, very quickly. No, that's okay, yeah, that's it, yeah. All right. So the possibility of that project came also from physicists, because physicists had money at the time. They were at the peak of their prestige and at the peak of their financial prosperity. And physicists realized, the quantum physicists, that the previous quantum generation created something as fundamental, kind of as maybe a kind of an all-time big events in history of science, but some of these people started dying. Kind of Einstein died, Schrödinger died, Pauli died, and that alarmed some physicists, kind of, and prompted them to give money for historians to interview those of the classics in the quantum field that were still alive. And that money was given to Thomas Kuhn, and in the course of 3 years they created kind of an enormous breakthrough in the field. So in some sense, their job as historians was to try to, even though they get money funding from the physicists, the main job was to emancipate the field from physicists and make it professional kind of as a historians. And I still don't know how they actually managed to do this, but they conducted kind of just a handful of people, maybe 5 or 6, conducted 100 very long oral history interviews and collected documents over 100,000 pages. I mean, not a single person can read all these pages and study, but in the course of very few years, they created an enormous bulk of resources that in some sense we can say served ever since then as the foundation of the discipline, because kind of most people who did quantum history at the time will have to kind of go around this kind of the sources and study this, these sources. Mm-hmm. Around this effort, there were I think 3 approaches, methodological approaches. One that was inspired some hosts initially, but eventually turned out to be a hubris, was to develop a very, we can say, invasive intellectual history. So the job of these historians was in some sense to destroy physicists' own myths. Physicists, once they developed certain ideas, they reconstructed logically kind of their path to it, and then came historians and were trying to prove the physicists. The historians knew better how these physicists came to came to their discoveries, and they could do so because they had documents, they had letters, they correspondence, and could show how this development of ideas can actually have a much more complicated route through many stories. But because of this historians' power to correct physicists' myths, they also felt that they could actually reconstruct, I would say, kind of invasive history of science, kind of to follow the path of discovery, kind of much better than physicists themselves could do so or could remember. Eventually, that proved out to be maybe a too ambitious a goal, but that was largely kind of the thing that was kind of motivated many of these stories at the time. Sorry, no, one. So this is the intellectual approach, kind of follow the thinking, and because there were so many letters, so many debates kind of recorded, kind of they could do in very much detail. The second, another methodological approach was, we can say, disciplinary. Because it was 1960s and 1970s, the time of big science, where scientists were aware at the time that how much of their work depended on funding institutions, kind of, and large communities and demographics. The historians also projected that back into the early periods of 20th century and started counting the money. We can call it follow the money approach. Sort of where did the funding come from, how many positions there were, kind of who funded this or that project. And there were several important kind of a breakthrough in that direction, in particular Paul Forman's study of the institutional situation in German physics after World War I, and a large survey by Forman, Halbrand, and Spencer Weird about kind of very detailed, very painstaking, very boring counting how many positions for physics there were around 1900, kind of trying to do all over the world, but so how many physicists were actually funded and existed professors at the time, kind of and what they were doing. The third approach was just at that time only at the very beginning. It was, we can say, the cultural and social history approach, mostly exemplified by Paul Forman's, by the famous or infamous Paul Forman thesis, which at that time created a lot of scandal and what was considered controversial. But what was considered controversial at the time, generation later became mainstream, more or less. Kind of a approach to quantum physicists by analyzing how they were dependent kind of on cultural and philosophical trend at the time. So what partly created the scandal initially was the idea that pioneering revolutionary quantum physics couldn't be influenced by reactionary conservative philosophy. And that was kind of considered shocking and subversive, but eventually we as historians at least get used to that, and many of this kind of a cultural approach kind of late, at that time it was just only the very beginning, but eventually kind of became more kind of a general kind of a generally used approach as a methodology. And the last thing that I want to say is that there was a for history of science, and generally for history, having too many sources could be almost as bad as having too few sources. And partly kind of what this approach did, but also what it did not, or this kind of accumulation of history of science. On the one hand, they created an enormous amount of sources that more or less channeled for generation of historians' activity into studying the source in that direction. But the sources also reflected some of the constraints that physics community had at the time, and did not, and more or less distracted historians from looking some other things that were not included in that generation, in that collection of the archive. Part of this was emphasis on theory and not on instruments and an experiment. Part of this was looking at the kind of when sources were created, Copenhagen interpretation was considered the definitive and the mainstream, kind of, and not paying attention to kind of other philosophical disagreements. Part of this was looking at the initial quantum theory, but not its applications, like, for example, condensed matter or many-body theory, that was excluded. Part of the constraints was that, of course, it was mostly Europe-oriented and United States, but not looking at the other geographic places such as India or the Soviet Union, to some degree, but only in a very limited. And part, as we already heard, that kind of women were to some degree represented, but certainly not in an adequate manner, kind of as that. But because they created so many sources, kind of most of the participants in the field, most of the members of the discipline, felt more or less kind of moved in that direction, kind of rather than look, and something that was kind of the following generation kind of followed. And towards the roughly 2000s, that created, I would say, a sense of partial disenchantment. So some of the initial hopes didn't work out. By roughly the year of 2000, we have a 10-volume narrative of history of quantum theory by Mehra and Reichenberg. I think it's almost 10 volumes. I forgot exactly kind of how many, which in some sense created a huge narrative. But on the other hand, for the initial pioneers of this kind of development, was a disappointment because it was a narrative very long, but kind of lack of argument, a lack of kind of important questions. But on the other hand, also why too many sources sometimes can be also curse, as Marabella book showed, that when there are too few sources, historians could develop contradictory theories, kind of using their speculation. Where too many sources, historians can develop contradictory accounts because sources contradict each other. And Marabella looked at this kind of, for example, at the Copenhagen philosophy and realized that even though it was considered to be a dogma, but there were so many contradictory kind of formulations of it. And in some sense, historians were could choose whatever they wanted if they wanted to construct a certain argument. All right, but for the most part, I think what happened after the 1920s is that kind of the community started moving to questions that had not been addressed by the previous generation.
Okay, so good morning. So I will read the text. So first, I would like to thank Daniela and Alex for inviting me to take part in this roundtable. Closer, okay. First, I would like to thank Daniela and Alex for inviting me to take part in this roundtable. It's a pleasure to share this session with Elise, Alexei, and Jean-Philippe. In my opening remarks, I would like to present a brief history of the research on the history of quantum mechanics. There will be some overlap with Alexei's opening remarks. I'd like, in particular, to suggest 3 moments, namely the period from 1958 to 1978, then a second period from 1978 to 2005, and finally a third period from 2005 onwards, and that's the last 20 years of research on the history of quantum mechanics. So around 1960, as Alexei mentioned, a few historians of science, under the leadership of Thomas Kuhn, initiated a project called the Archive for the History of Quantum Physics. The goal of that project was to collect, organize, and to describe the personal archives of quantum physicists. The goal was also to conduct a series of oral history interviews. The project was a great success. The personal archives of 279 physicists were collected and organized, including the voluminous archives of Niels Bohr and John Archibald Wheeler, and 107 interviews were conducted, which initiated the collection that now is known as the Oral Histories of the American Institute of Physics. All the material was then microfilmed and distributed to archives and libraries in the United States and Europe. This archival effort enabled the beginning of the serious research on the history of quantum physics, culminating in the celebrated works published in the 1970s by Thomas Kuhn, Max Jammer, Paul Forman, John Hybro, Gerald Holton, Linda Wessels, Martin Klein, among others. However, perhaps due to the proximity of the protagonists of their stories or their historiographical backgrounds, this author presented narratives that, over time, revealed their limitations, as would be expected for a topic receiving its first professional historical approaches. The next generation of historians of physics ended up becoming more interested in other topics, for instance, the history of relativity theory, mainly due to the Einstein paper project. The work on the history of quantum physics produced during the 1980s and 1990s, while sometimes very good, were more the result of isolated efforts than a collective project. So much so that there is little in common between these authors' approaches to the history of quantum physics. A number of well-known authors wrote about the history of physics in that period of the 1980s and 90s, such as Johan Bromberg, Catherine Chevalet, Michel Paty, Mara Beller, James Cushing, Olivier Darrigol, Sylvain Schweber, Arthur Miller, Peter Gallison, Andrew Pickering, Abraham Pais, Yadish Mehra, Helmut Reichenberg, Alan Franklin, and Harry Collins, among others. However, the situation changed around the year 2000, when a new generation of historians of quantum physics, those gathered here, began to systematically question the assumptions and the categories of that, analytical categories of that generation of the 1960s, 70s, 80s, and 90s. The old narratives and their periodization proved somehow inaccurate. In particular, this generation engaged with Max Jammer, Heilbronn, Beller, Forman, Klein, perspectives about the history of quantum physics. So, for instance, Jammer's very famous idea of an unchallenged monocracy of the Copenhagen School, Heilbronn idea of the missionaries, the early missionaries of the Copenhagen spirit, and so on. Gradually, a community of about 50 researchers from different locations, initially 50 researchers, nowadays a much larger community, from different locations, including Germany, the Netherlands, Spain, Brazil, France, Denmark, Canada, China, Japan, the US, Australia, Greece, among other countries, took to themselves the task of rethinking the history of quantum physics. Due to the considerable sophistication in the training of historians of science over the last 50 years, this generation brought with them, in addition to a solid background in contemporary physics, a sophisticated historiographical toolkit, sometimes derived from cultural history. And that cultural term has many sources, for instance, the Forman's thesis. And that generation also had this interesting aspect that this generation went beyond the old internalist-externalist dichotomy. So that's an interesting aspect. The result has been the production of historical narratives centered on scientific concepts and biographies, but permeated by a complex social fabric. Just one second. So this community has met regularly, particularly in this History of Quantum Physics conference. The first two, called HQ-0, HQ-1, took place at Max Planck Institute for the History of Science in Berlin in 2006 and 2007. The next conference in the HQ-2, took place in 2008 at the University of Utrecht in Netherlands. In 2010, the HQ-3 was held again in Berlin. In 2011, some members of the community met at the Continuity and Discontinuity of the Physical Science since the Enlightenment conference held at the American Institute of Physics, College Park. In 2013 and 14, the Seven Pines Symposium in Stillwater, Minnesota, devoted 2 editions to the history of quantum physics. Also in 2013, there was the conference 100 Years of the Bohr Atom in Copenhagen at the Danish Academy of Science and Letters. Several historians of quantum physics met again in 2014 at the Global Science, Global Technology, and Global Impact Conference, once again at the American Institute of Physics. In July 15, finally, the HQ-4 conference took place at the University of the Basque Country, or Euskal Herriko Unibertsitatea, in respect for the language, in San Sebastian, Spain. And in 2019, this community met again at San Sebastian, this time for the 3rd International Conference of the History of Physics. And this community also gathered at the International Conference of History of Science and Technology in Budapest in 2009, Manchester in 2014, Rio de Janeiro 2017, Prague 2021, and Dunedin, New Zealand in 2025, in addition to the History of Science Society meetings. So we met many times over the last 20 years. And that really created a community, shared problems and methodological tools. And now we are finally gathered once more in Salvador, once more here in Salvador, Brazil, for the HQ-5. The works presented in those gatherings are very diverse, and it would be impossible to present a comprehensive list of problems, methods, and approaches adopted by the community. Therefore, I would like to quote an article by Olival Freire that was published in the Proceedings of the HQ-2, that summarizes well at least a large part of those works. And I quote Olival. Diverse factors may have played their roles in the evolving controversy over quantum theory. Among these factors, it would be worth considering philosophical and ideological issues, professional biases, generation and cultural changes, and the diversity of the social and professional climates in which physics was practiced throughout the century. In addition to this, there were conceptual and theoretical breakthroughs, technical innovations, Gedanken experiments, and factual experiments, feats, as well as technological expectations. However, not all of them prevailed at the same time. In fact, in each diachronic slice of history, the working of only a few can be found. Therefore, the job of the historian is to disentangle the role played by each factor in each local and temporal context. End of citation. I think that citation really summarizes very well what we as a community have been doing for the last 20 years. Therefore, I look forward to discuss the perspectives on the history of quantum theory and our job as historians in this roundtable. Thank you.
I haven't got any slides. So as my fellows were speaking here, I was reflecting on my sort of more an anecdotal approach to these questions. So when I started graduate school at Notre Dame, the History and Philosophy of Science program there had been started by the Reverend Dr. Ernie McMullen, who on our first meeting regaled me with stories about how he would walk the hills of Ireland with Schrödinger. And I thought, all right, this is amazing. But what Ernie and others in the HPS program at Notre Dame really impressed upon me, who was primarily interested in physics and philosophy, and I thought the H can be sort of silent in the front of the HPS for my career. But they impressed upon me that there is no separation between these. And I didn't really know what that meant until I began attending conferences and workshops, especially in the HQ series, and seeing robust HPS work done. And it has drastically changed the way I do my own research and the way I teach. And so I think what I'd like to share with you all is maybe just how, as a philosophy professor, when I teach my philosophy classes, how integrating that with the history of science has really, I see the change it makes for my students, and to encourage you all to be brave as historians and to interact with your colleagues and to continue talking to those folks in STEM. There's so many things that I want to say, but I don't know what to say. In the US, there's a myth that science is the story of men in rooms thinking up great ideas. And so I remember traveling to Cambridge to give a talk when I was a wee graduate student, and I was giving a talk on philosophy of physics. And I was a guest at one of the colleges, and I don't know if you've been to the colleges, but in the dining rooms, it's a very Hogwarts-esque situation, but they have portraits of all the famous people who've graduated from that college all around the hall. And the college I was at, there was a tiny little portrait of the Queen, because this was back when she was around, and then it was all men. And the physical feeling of just literally sitting below them and feeling just unwelcome, it was just so impressed upon me. And if you remember the slides from Margret's talk yesterday, I'm in philosophy and in physics, and those are the two disciplines way at the end of that. But when I went to HPS conferences, and specifically the HQ, even though I think in the early days I was one of very few women in the room, there was a sense of collaboration, because the field, there was so much raw material, there was so much to be learned, and it wasn't just a case of great men in the rooms thinking of ideas, but of the Foreman thesis, right? That a person's culture made a difference, that science was a sociological, social endeavor, that there were philosophical questions to be, whose depths could be plunged. There was such a collaborative atmosphere right away that I felt very much at home. And now it seems that this is just increasing, and that makes me very glad. So let me say a little bit about the teaching bit. Again, with the myths of how science works, is that it's sort of a linear progression toward truth, and that it's done by individuals alone based on their brilliance, and that it's done by certain kinds of people with certain kinds of training. And to be able to teach STEM students in my philosophy of science classes the history of quantum mechanics as a case study, because most of them are not going to be quantum physicists, but to have them read the actual letters that Heisenberg and Einstein and Hermann and these guys exchange with each other to show them that the early thinkers, the early physicists, were also very concerned with philosophical questions, is eye-opening for them, because it gives them permission to ask questions in their science classes that they would not have asked. It gives them permission to say that different ways of thinking and approaching a question are not only necessary, but like incredibly beneficial, right? Even when I was studying physics, I never, in my cohort of physicists, some of whom went on to like Harvard to do their PhDs in physics, like these were bright people, I never solved my problems exactly the same way they did, and I got fine grades and everything, but I just approached things differently, and I felt like that meant I shouldn't be a physicist. But studying the history has revealed just how important these very different approaches, and you can see this again in the correspondence of the early quantum physicists, was exactly how they made progress. And so demystifying and demythologizing what science really looks like, using the history of quantum as a case study, has been really rich. And then I will end by saying that I had the honor of speaking at the opening night of the Helgoland conference with 300 physicists and all these Nobel laureates or whatever. And they had three people give history talks on the opening night. But the first person was a physicist from Yale who had no training in history, and he was a wonderful guy. But I mean, it was not historical. It's like, okay, physicist, you know there are these other fields, right? And the other was Philip Ball, who's a popular science writer, also wonderful. But I was the only one there who had training in history, and that this is still the perception of how history of physics is done, to stand up and just sort of say, oh no, we have this really rich set of tools, come and play and come and engage. Was eye-opening. I was able to have a lot of conversations, not with the older physicists so much, but with the young folks who are postdocs, early career right now, at different labs throughout Europe. And I was so encouraged by my conversations with them and the sort of historical philosophical approaches that they bring. I lied. I want to say one more thing, which is because I spend some time in metaphysics, analytic physics, which is like, grrr, right? One other place where they desperately need the H in HPS is because the debate about interpretations of quantum mechanics and other sort of ontological questions in philosophy of physics has stagnated, and it's been stagnant for like the last 20-some years. And that's because these historical accounts are not known and appreciated. So I've been trying to, and others have been trying to bring back into the contemporary philosophy discussion the nuanced approaches that the different historical characters had. And even just saying it's not just about having an epistemic versus an ontic approach to the wave equation, because that's what the debate boils down to. It's like, oh no, there are neo-Kantian approaches, and there are quasi-realist or structuralist approaches or whatever, and we see these modeled by some of the historical figures that we study, just opens up that field as well. So, yay, history. Conclusion.
Good morning. Thank you very much, Daniela and Alex, for the kind invitation. But I need to start with a disclaimer because I feel a bit like an imposter. Not only because I'm working currently on general relativity, but also because even if we are here to reflect on the past 20 years, I consider my real entry into this community to be 2015 when I attended HQ-4. Actually, HQ-4 was a decisive moment for me since I met for the first time the core community which really shared my interests. It opened new perspectives, leading to my first published papers, including one in special issue that followed. And also it was an opening to other important events, notably the Quantum Culture Symposium in Rio, organized by Thiago and Christian Joas. And perhaps through domino effect, it even played a role in securing my first postdoc here in Salvador in 2018. So maybe the first thing I want to underline is that we need conferences like this, and 10 years between HQ-4 and HQ-5 feels too long, especially for early career researchers who can really benefit from them. Still, the peak of my sense of belonging to the history of quantum theory community came during my period in Salvador when Olival invited me to contribute a chapter to his collective volume on the history of quantum interpretation, focusing on quantum theory in the Soviet Union. It was a wonderful opportunity to synthesize 10 years of research, and I remain very grateful for it. But that chapter also marked the end of a period. From then on, I gradually moved away from what is usually seen as the core of quantum historiography, first towards particle physics, and more recently towards the history of general relativity. Still, through these changes, I have never seen the history of quantum physics as an isolated field. For me, it also gains meaning in dialogue with other domains. The stories, actors, methods, and institutions I study often form bridges that keep my interest in quantum history alive. So working across several fields then constantly reminds me how porous their boundaries are, and this leads me to the basic but essential question: what exactly do we mean by historiography of quantum physics? At its core, it covers the history of quantum mechanics, but beyond that, it seems to me that the boundaries are less clear. Should studies on particle physics, condensed matter, nuclear physics, quantum chemistry count as part of it? I personally favor a broad definition, both for the richness it brings and for the institutional stability it can help create. Actually, over the past 2 decades, I believe many boundaries have been pushed, making the field more global, more diverse, and more representative. And I want to address that a little bit. So, of course, gender studies have brought fresh perspectives on the actors, institutions, and narratives of quantum history, as Marguerite showed so well yesterday. Also, global consideration have flourished. In Brazil, works by Olival, Indianara, Ivan, who are all here, and others have traced both the reception of quantum theory and the building of local research cultures. Similar developments have taken place elsewhere. In China, we'll have a presentation about that by Danian right after, but also in China, only to mention those contexts. And this connects local context to global scientific dynamics. Material culture approaches have also gained momentum from early contribution by Johan Bromberg and Wilson Bispo to more recent work, such as the contribution of our main organizer, Climerio, who reflected on materializing the foundation of quantum mechanics. These studies remind us that instruments and experimental practices are also central historical actors in some sense. But beyond these themes, I also believe the scope of quantum historiography has also expanded, often in ways that are not fully reflected in the HQ conferences. And it connects to major subfields that develop in the post-war era. It was the case of nuclear physics, quantum optics, and quantum information. And while I do not really have time to expand on each of these, let me briefly address a few others. So particle physics has developed, the history of particle physics has developed, notably through the history of quantum field theory. And here I want to underline the work of Alex Bloom on scattering theory and of Marcus Eberger on virtual particles that have actually helped to bridge quantum mechanics with high energy physics. Condensed matter physics has gained renewed interest with studies by John Martin or more recently Nuria Munoz Gargante, who showed how it became fertile ground for testing and extending quantum ideas, sometimes in tension with high energy physics priorities. Works on quantum chemistry, as in Kostas Gravoglu and Anna Simoes' Never Physics Nor Chemistry, revealed how quantum theory transformed chemical practice while challenging disciplinary boundaries. And quantum gravity has also attracted major interest, most notably in Alex Bloom's group at the Max Planck Institute in Berlin. This group, which unfortunately concluded earlier this year and which I was fortunate to be part as a visitor, played an important role in continuing the tradition of quantum historiography in Germany, offering you researchers excellent working conditions and placing a strong emphasis on excellence. It was perhaps one of the last strong institutional anchors for our field, and I believe we need more initiatives of this kind, whether in Utrecht, Salvador, Copenhagen, or elsewhere. Taken together, these developments suggest a field increasingly comfortable with porous boundaries, where historians can move between subfields, geographies, and methods without losing sight of the larger narrative. One trend I find especially valuable in this broadening is a renewed focus on the history of concepts. The practical turn in conceptual history, as developed by Friedrich Steiner and Ingo Bringen, for example, shows that concepts gain meaning only in relation to others, within concrete scientific practices. Oliver and Thiago made a similar point in their 2015 study on the uses of Bohr's idea on quantum field measurement. And a very good example of all of this is Marcus Eberger's work, recent work on virtual particle, which invites us to shift our focus from intrinsic properties to the role concepts play and how their representation are mobilized in specific context. So to conclude, I see the past 20 years of the historiography of quantum physics as marked by plurality, constant evolution, and enrichment through cross-field dialogue. It has been shaped by a shift towards social and practice-oriented histories, by the inclusion of post-war developments, and by increasing interdisciplinarity. Then perhaps if I can already address a question, not to the audience, but to the next roundtable, it would be, how can we ensure to turn our diversity of perspective on historiography of quantum physics into a shared strength rather than a source of fragmentation? Thank you.
Many thanks for this wonderful contributions to all of you. Now, if you wish, there is the time for you to follow up on these inputs. All right, shall we start right away with taking questions from the audience? All right, okay. To add later, okay. Yes, all right. We are opening the floor to questions. So I will come to give you the microphone. Yes, are you?
Well, thank you, Daniela. I have 2 comments / questions. The first for Alexei. You presented Forman's Weimar paper as an example of cultural history. I'm not sure if this it's the best manner to present that seminal paper by Paul Forman. At least I think that he himself would not recognize himself in this label of cultural history. As you certainly know, there was a very intense debate between some 10 to 15 years ago between him and Norton Wise. Norton Wise as the proponent of the cultural history approach in history of science, criticizing Paul Forman because Paul Forman looked for sociological causation in this paper. And the Forman reacted with a draft which was unpublished till the publication of the Oxford Handbook that we have together edited. If you read Norton Wise and the Forman's answer 15 years later, you can see that they do not agree about what is, or at least they do not agree, or at least Forman would not agree being portrayed as a representative of the cultural. So I think that form a seminal paper, as important as it is. For me, it's a good example of the strong influence of sociology in history of science, because he looked for sociological causation. I would like to listen a little bit about this. And the second is a question related probably to Tiago, and a comment related to Tiago and Jean-Pierre. I would like to emphasize that the HQ series of conference, as important as they were, it is not comprehensive enough to understand how the field of history of quantum mechanics developed in the last 20 or 25 years. We had a strong example yesterday, the nice talks, very magnificent talks by Marguerite and by Hanok. These are things that came completely independent of the HQ series, which is not a problem for the HQ series. The problem for the HQ series is what Jean-Philippe has emphasized, as I understood, was one series of conferences which lasts 10 years to have another edition. This is not a series. So if this series, for you who will continue the discussion, unfortunately I will be not here in the last 2 days. If we want to continue this kind of conference, if it is really important, we need, I think, a different institutional basis, because as it was in the past, it was strongly dependent of the funding, German funding for the Max Planck Institute. And when this fund ran, the HQ just went to an end.
Yes, we can call it social cultural history or sociological cultural history, but I agree that sort of a Foreman, in some sense, went too far or maybe overstated, and indeed kind of ascribed to kind of a very strict causal kind of a sociological explanation, which later cultural historians kind of broadened up kind of and added kind of, let's say, more complexity or nuance. I would want to maybe compare Foreman's role in that case to what Schrödinger did to quantum mechanics. Even though Schrödinger's initial formulation of wave mechanics, but later proved to be maybe too narrow or too much, too, let's say, going to at least too far. But it did open the gate, kind of. It did kind of open the way for other people, kind of, to broaden the approach and things. So kind of, so in this sense, kind of, indeed, Foreman's initial formulation was kind of maybe we can say too polemical or too kind of too deterministic in its own case, but Foreman thesis did allow kind of many further studies to go kind of and continue and to kind of to broaden the field.
Started a conversation. Yeah.
What was it like? Open the gate.
You just said you were right about everything.
Yeah. No, Oliver, you understood me well, and but I also think that having more of these conferences would help to be more representative of the diversity of the field and of the other currents that were not present in former conferences. Yeah.
So thank you very much, Olival, for the comments. I would like to add one thing to what Alexei said, and then to answer the comment about the time since the last conference. As your former student and as someone who learned about the Foreman thesis with you, I completely agree that Foreman thesis itself is not a cultural, a typical example of a cultural approach to the history of physics. But there is some irony in that, because when we look at the conference that Alexei organized with Catherine Carson and another author that I don't remember the name, in 2007, I think, in Vancouver, in honor of the 40-year anniversary of the Foreman paper, and many of you were there, like you, Richard, Anya, and others. And when you look to the published book that came out of that conference, I would very much characterize those authors as cultural historians of science. So even though Forman thesis itself is not cultural history, the historians that took Forman thesis as an example, as a model for their own craft, they are somehow historians of science that have a very strong a cultural approach to the history of physics. So it's somehow paradoxical that a paper that I agree is not about cultural history of science has produced, like, has impacted on works that are somehow about the cultural aspects of physics. That may be a little bit ironical. We can develop it further, but I have this feeling in myself. And the second thing that I would like to answer is that I completely agree that 10 years is too long, but since the last conference. But of course, there was the pandemics in the middle. So since 2020, things got a little bit complicated. But even before that, what I was trying to show is that there were many gatherings of that community, not only in the HQ series, also in other conferences. And therefore, even though there should have been perhaps an HQ conference after 2015 and before 2020, even despite the fact that there was no such a thing, no HQ-5 before 2020, the community still had some sort of like connection because it gathered elsewhere. So I really think there is this, for the first time in the history of quantum physics, this sense of a community in the last 20 years, and I hope very much, of course, that we keep that on in the next years. Okay, thank you.
Thank you so much for this rich panel that starts with a kind of recount where the history of our discipline has come from, and adding to it personal anecdotes, which makes it very rich. So my question is a little bit on that. If we look at the history of our discipline or our research focus, whatever you might call it, how do you see it within the wider scheme of cultural and financial and structural developments? Let's say over the 20 years, we don't have to go necessarily back to the mid-20th century. Because this lacked a little bit for me. How does this discipline also answers to maybe certain currents that are of cultural interest? And I don't mean particularly gender studies here, even though Jean-Philippe pointed it out, how important it is. And I also don't mean the different turns we have in our disciplines, but how does it sit and shift, kind of, why do we have maybe an HQ-5 this year beyond the quantum century? Like, is there maybe an urgent need that we all feel that we have to answer to? Or we felt maybe a little bit lenient over the last 10 years where we didn't feel like the pressure that we have to come together.
Perhaps this is not exactly what you're saying, but maybe a small response could be, I do think we have to, in some sense, continue to be evangelists for the discipline as we practice the discipline, and that in our pedagogy, but also when we interact with people who are in broader, like just in history or philosophy or whatever. And it's a burden, but also when it works, it's a joy, because the zeal of the new convert, right? Someone who, and we've had that experience ourselves. Maybe, at least for me, I thought of history as like the primary colors in a Crayola crayon set, and then when I got into the archives and saw the stuff and understood that they were talking to each other in these ways, it was like seeing this huge spectrum of colors. So I think the proof can be in good HPS itself, right? But yeah, I do think we have to continue to, the burden is a bit still on us to get others to understand what the discipline is. I think. I could be wrong, but yeah, I think we have to self-promote a little bit.
Mm-hmm. Yeah. maybe it's partly, I'm not sure it will be answered the question, but on the one hand, there is indeed a frustration that physics, after the great intellectual breakthrough in the early century, since then kind of didn't produce something kind of comparable. But there was something else going on in society, and I think partly what we're lacking here. So Jean-Philippe was trying kind of to expand the field, or not to expand, but to broaden the field. Kind of, I would want to push in even further and says it's so in some sense, quantum has gone much wider kind of in the culture. It's not longer owned by physicists. It's owned by anybody else. Like at least what kind of I think what we need to include in this community is technology. Quantum technology, kind of something that, because it is everywhere, kind of, and something that has been happening kind of in the kind of recent decades, kind of, and this is where maybe kind of the major thing was happening. But also well beyond it, I mean, I'm not sure how to deal with that. But if you kind of look at literature, there is a book about how quantum became a cultural buzzword. There's a book about quantum politics, whatever it means, basically. It claims that previous politics was based on Newtonian concept, but now the new politics has to... Don't laugh at it, you know, it's serious. It's a kind of serious political science. If political science is a joke, but still. There is, if something is wrong with your health and the usual medicine doesn't help, you can go to a place called quantum healing, and they will do with you, I don't know what, but they will do something. Or if you want to get rich, you can go to a place called quantum finance, and they also do something. So the thing is that kind of once upon a time that considered to be atomic age, where the word atomic was fashionable, it was attached to anything. Then the word atomic became kind of a get out of fashion, but now it's quantum. It's considered to be sophisticated, somewhat mysterious, can do things that you don't understand what, but it's not dangerous, kind of. And now you can kind of attach it to kind of almost anything. And in some sense, it's part of quantum history. I don't know how, but or how we can include it.
I'll just add to that, yeah, quantum cryptography, quantum communications, quantum computing. This is where the startups, this is where the money is, but it's also where there are people who are latching on to pretty crappy philosophy, pretty crappy history. It's young, fresh, full of money. Go get in on that because they need good thinkers to be in there from the start, and maybe then that can avoid some of the stuff that with like non-relativistic and early relativistic quantum theory, there was a bit of a lag between the history and the discipline itself, but we can get in on the ground floor here, right?
Hi. Thank you all for organizing and for the talks of the panel. I have a question that basically is what we can do as a community to make your work better or to gain strength in our working in a collective way. I'm thinking about it because somehow I was thinking in a point that in the end Jean-Philippe presented that one of the most fascinating parts of the history of physics that we can do history of physics in different perspectives, in different historiography. I can have a social perspective, a cultural perspective, a philosophical perspective, and in my opinion, this is the most fascinating part of our community. But at the same time, I'm not so sure if we are able to understand each other, and when we adopt one perspective, if we can if it's easy for us to communicate, to understand each other, and what we could do as a group working together to build bridges between these different perspectives. And also thinking in what we can do in a collective way, when you try to do this history of quantum mechanics, we always goes back to archive of the history of quantum mechanics. And if you think that it would be possible to have some collective projects around sources in history, because I don't know if I'm completely unupdated, but as soon as I know, the microfilms of this project is not available anywhere. And it sounds for me strange that after 50 years, this microfilms that is part just for 2 or 3 groups, and everyone else that is in other parts of the world can't have access in it. So but is it available? Okay.
Yeah, I was talking to Christian about that. So I was talking to Christian Yoas about that, and as well as Alex Bloom, because there's some talk around doing some digitization projects around IYQ. And so my understanding is that the Max Planck Institute digitized essentially all the microfilm, but that was behind like a sign-up wall, because the rights question is the major thing that needs to be resolved. And now that the Max Planck Institute is no longer doing that, Christian said that the Niels Bohr archive had acquired those digitizations. So it's really a question of, one, how do we liberate those by securing any necessary rights that need to be secured? And secondly, the quality of the microfilm, I understand, is quite uneven. And so would we want to actually go back to the original sources and do it again with non-1960s photographic technology? And there's a possibility we could get resources to do that. We were also recently talking to the American Philosophical Society about digitizing the audio of the oral histories. And they just got denied for a grant to do that, but we're gearing up to take another swing at it. So. But there again, though, the rights is another question where we need to be much clearer about what needs to be done for those not only to be preserved digitally, but to be made public across the entire world.
Well,
Okay, so about your first question, Ivan, I think, yeah, sorry, about Ivan's first question, I think it's complicated because it's from one side we want to have like a plurality of problems and approaches. That's a good thing, like to have many different problems in the community and different methodological and theoretical historiographical approaches to those problems. So plurality is something good, but it can lead to fragmentation of the community. So we have to struggle at the same time to be like in touch in order to continue to understand ourselves as a community that is gathered somehow, even though we have this plurality of problems and approaches. The only way of doing that, I think, it's meeting regularly. So that, yeah. But we of course, we have to think about that also in the training of young generations and so on. But I think we are doing that very well. So perhaps the only thing that we should do, just as Olival said, is that we should not accept another 10 years to the next conference. That would be, and as Jean-Philippe said, that was a very important, like you said, many very interesting things, but one of the things that touched me a lot was, for young scholars, 10 years is a long time. Like for someone who is beginning the career, like if you stay 10 years without meeting the rest of the community, it's yeah. And about the archives for the history of quantum physics, many years ago, I attempted to bring one copy of the microfilm to Brazil. Like I discussed the matter with many people, and the problem was that the library here at University of Bahia was microfilm is an old technology. Like we don't have anyone to be responsible, because when you accept to be like to have a copy of that, then you have to open it to visitors. So it must be some sort of archive that has like someone ready to welcome people that want to use that. And of course, if there were a copy here, people from all Latin America would come here to use it. So it's complicated because so digitizing is the best way. I really believe we should solve this matter collectively in the future, in the near future.
can I add just a little thing about the first point? I think it goes further than just meeting at conferences. I think it also means sitting together and discuss about our approaches, our methods. And for example, Bernadette is doing great work while organizing the consortium meetings regularly, discussing papers, having people talking more about methodologies, approaches. And yeah, I think it's a bit more than just conferences. Yeah.
I'll just double down on that and go even further. I think how to avoid fragmentation is not as much methodological problem, but a sociological problem. And the way to deal it is to meet together, to listen to each other, to meet at a conference, and ultimately not just to get the sense of belonging, kind of that you're being heard and you listen and you're being heard, and kind of, and what you do kind of is understood by others, even if it's can be methodologically very different. And ultimately, why I encourage it's also bringing caipirinha together, kind of, and at this point, you really feel the belonging to the community.
You came to one of my talks with a coconut drink. That's when I felt I really belonged, if you felt comfortable bringing a coconut drink.
Hi. Thank you for sharing all your thoughts. I want to take a bit of a step back and ask about what the history and historiography of quantum mechanics has contributed to the broader history of science, and also what there's to learn from the history and philosophy of science and technology in general for us, and do better history of quantum mechanics. Yeah.
I can only say what I think we've not done as well as the rest of history of science and medicine, which is history of quantum and history of physics remained internalist for so much longer. But we're fixing that.
I can do a little positive, but of the early period. I'm less confident about the recent one, because the recent one, like for example, gender studies were kind of simply behind kind of the rest. But on that period I was talking about, much of what that generation did in quantum physics was actually breakthrough methodologically for the entire history of science. For the first time, they were doing oral histories. I mean, such thing did not exist in history of science until they did it in quantum thing. Kind of being proactive, kind of being collecting documents. So, kind of at the time, kind of the sort of the original Sturm und Drang period that I was talking about. At that time, the quantum history of quantum physics was methodologically ahead of the rest of history of science. Kind of at some later point, it was lost, but.
It's just informative. There is also an article by Massimiliano Badino on Centaurus. I think it's also open access, which is what quantum historians have done for us. It's a little bit outdated. It's 10 years, I think. But there are some good points there, sorry.
Yeah, that's very good. You were first? Okay, sorry.
Is it on? Yes, okay. Well, my question was basically, I think, answered already by Elise, and I was, I think, picking up on what Elena was asking, responding partly to it, and then asking my question. So I think, because Elena, I think, was asking how the history of quantum physics responded to general trends in the humanities, something like this, at least partly. And I think it did a little bit, but not so much, I think, as other parts of the history of physics. And that's basically my question. I wanted to get back to you, if you agree with my perception there. Okay, Elise agrees and thinks it's not a good thing. I actually think it's a good thing. But yeah, if you could comment on this a little bit. And then a bit more specific question. Is from the history of the history you've been telling, did I understand correctly that basically the institutional and systematic history of physics began with the history of quantum physics? Is that correct? In the 60s with what Alexei and Thiago been saying?
I mean, history of astronomy was way at the beginning of HPS even, right? So I don't think history of quantum physics, but maybe Alexei, yeah, you can.
No, partially what was going in the 60s is that the previous history of science was more focused on much earlier periods of time. And it was less common for them to deal with relatively recent things. And in this sense, the project of history of quantum physics was kind of also pushing the boundaries in the sense that they were dealing with a very recent kind of a thing that of when the participants were still alive, or at least some of them. And that was changing the field because the previous, there was history of physics, but it was about Newton and much earlier centuries.
I don't think I quite understood the first question that you asked.
You agree that the history of quantum physics responded less to trends in the humanities than other branches of the history of physics?
Yeah, no, I think that's right. Right? I think it's, I mean, the threat, like, I mean, if you want to do good history and philosophy of a particular science, I think you have to know that science. And a lot of the people who could have made really interesting contributions that would keep the history of quantum physics in the current were not welcome in those spaces or something like that. So I think for a long time it was people who had been trained in quantum physics who were primarily doing this history, and that was just a small slice of who could contribute interestingly, maybe. I don't know. Do you agree, disagree?
I could share some reflections on that. So I think when we talk about the history of quantum physics, there is a very complicated, difficult thing that is sometimes it gets very technical, and some of us do very technical histories of physics. And at the same time, I believe we should make an effort to even though we may write about very technical subjects, to communicate that reflection and to try to draw some general conclusions out of that. I believe the first generation did that in the sense that, or the first and second generations that I mentioned did that in the sense that they somehow try to do some technical work, but at the same time to draw philosophical and philosophical in the sense of how theory changes. I'm not arguing us to go back to those old-fashioned philosophical models of theory change, but we can draw some general philosophical conclusions out of the more technical research we do. So in order to communicate what is the final conclusions that we arrive despite the technicalities, and if we do that as a community, then I think, so I'm approaching Bernadette's question, but also Elena's, we can still be part of this humanities debate, or we can join historians as in order to share with them perspectives. I think it would be a mistake to, and I do very technical history of physics, but I think we should not only do that, and we should try to really communicate with historians and philosophers what we are doing. And that's also an answer to what Ivan said. If we do that, then we can perhaps more easily share problems and methodologies. So yeah, that's something I would like to see us doing in the future.
First of all, good morning and thanks for the talks. My question is to Elise Crew. I'd like to know if you could comment more about your work, your approach in this connection between physics, metaphysics, and contemporary philosophy. And I'm asking that because my graduation was in physics, and both my master's degree and PhD were in philosophy, not in history, although I'm always mixing history and philosophy. But when I'm talking about metaphysics and physics among philosophers, and not necessarily philosophers of science, they always demand me to talk about Kant, Hegel, or the German idealism, and that's not exactly my approach. So when you said that it's difficult, it's hard, this connection between physics and metaphysics, and you are more interested in connection with contemporary philosophy, his commentation. So I would like to know how do you manage this, the way you work and so.
That is a question maybe we can talk more about during the break. But it is one area where, I mean, maybe this is a better response to the question, is like, I really do think that, I can't speak to the phenomenology side, but that is an area where contemporary metaphysics in the US needs to do much better, because analytic metaphysics is considered entirely separate from the names you mentioned. But that's, you know, that's changing a little bit. I mean, Stephen French's new book on London and Bauer and phenomenology is fascinating. I still don't understand Hegel and don't know if I ever will. But that's promising. And in the same way that sort of reminding the philosophers that there is this rich history and that it in fact gives us more nuanced ways of thinking about the same questions, I still get resistance from that. I mean, I don't want to name names, but like T. Maudlin, no, maybe Tim M. is better, often wants to talk to me. He's like, yeah, but forget the history. Just answer this question. I was like, no, but the point is that the history itself shows us that there were a diverse and really nuanced approaches. But of course, when these guys were being trained, the history was a little bit more, you're a realist or you're an anti-realist or whatever, and they maybe haven't been brought up to date. So I think part of it is, again, evangelizing for sort of the history of that science as being a way that makes the philosophy so much richer, because it just gives us new ideas and new approaches. And history is really good at listening. Philosophy sucks at it. So this is a way that people with this cross-disciplinary training can help to heal our sister disciplines, maybe. Yeah.
But we shouldn't be afraid to engage with philosophers.
No. Most of us don't bite. Most.
Yeah, good morning. I want to come back to the gender aspect because I have the impression so far that we often just talk about women in the history of quantum physics or history of physics, and not about how stereotypes like the images, what is a man and what is a woman, affected the discipline, and also how the discipline affected our stereotypes today. And also, we don't talk about masculinity and all, I think, and I think that are also really important things we should talk as a discipline.
Hi, thank you very much for this wonderful round table. Thank you for your time to be here. And it's questions related to our early career colleague down there. So why do you think we are so afraid of cultural and gender studies? What are we afraid of as a community to learn from these approaches?
I know I've been talking a lot, but really quickly, I don't think it's not, at least for me, it's not fear. It's just that it is hard to find source material for, even for some of these initial categories that we've approached. So it's yes, yeah, that's my quick, like it is hard work and it is hard to do good history that way. So I think the bar to entry is just higher, right? Unfortunately.
I don't have any answer.
Oh. I don't know, do you feel fear about this?
No, I don't.
If I can give a very honest answer, I'm not afraid to engage with it. I'm afraid to do it wrong. And I very much welcome help from people who know how to address this question. But
it's not a different kind of history, it's the same, we are community. So
but
that's why we're using this term like afraid, because I think we are afraid of. So
But I still think there are some literature, some methodology that I've never been trained to address, which is something I need help, yeah, in a sense. I learned a lot last week, and it was great.
I think it's part of the answer I gave to Ivan. I think it's like this plurality of problems and questions and methodological approaches is very, very welcome. So, and I do think this is a topic that has been like approached like in the last 10 years or so. So it's quite recent. I myself did something on that in that direction. Yeah, so we are writing a joint paper, like very soon a joint paper on that. So I think it's a very welcome, but I wouldn't say afraid. Like it's just like something new that we have to learn how to approach. Yeah, I think that. So that's yeah.
I think here's a place where feminist philosophy of science, even though it's taken as its subject like primarily medicine and biology, is way light years ahead. So we can learn. But I will just say anecdotally, one of the reasons, there are two reasons why I haven't done it as much. And one is because I hate it so much when physicists get up and pontificate about a thing in which they have no expertise. I don't have up-to-date training in gender studies, whatever. So one of the reasons I'm not afraid, but I would rather invite somebody who does have expertise to join me in that is for that reason. Yeah. Don't want to do the same thing I've accused others of doing.
Oh yeah, okay. Just two totally non-connected comments. One on this eternal issue of digitization of the AHQP. The problem, right, is the rights of the personality rights, right, which go down to the air. So, which, you know, of course, with the course of time gets ever more complicated because it gets ever harder to track down who's like the great grandson of any person that was is included in there. And then, of course, the question is it worth that effort, given the quality of the microfilms, which are in part really bad, right? I mean, you know, from my own work on Schrödinger, can say what huge advantage it was when in Vienna they did a modern digitization directly from the original documents, not from some blurry microfilm where you often just simply can't read the handwriting, right? I mean, it's so it's a tricky question, but of course it's also tricky to now try to redo what was done in the AHQP because these documents are spread all over the world, right? I mean, it's not like, you know, we have like some easy access to track where I mean, we do know where Thomas Kuhn got them from, but there's no guarantee that they're still where they were in the 1960s. So it's unfortunately a very tricky thing, right? And you know, at the Max Planck we did a fairly good digitization of it. Unfortunately, now it's not even shown behind the wall anymore, right? Because, you know, that's the politics of the Max Planck. That, you know, unfortunately that got turned off altogether. So yeah, it's a sad story, but it's not easily remediable. The other question, the question of diversity of approaches, I think one advantage of having a focus in a specific subject field that is relatively coherent, like quantum physics is that we don't have to be afraid of a multiplicity of methodologies, and I don't think we ever were, right? I mean, yes, I agree that, of course, you know, the majority of people working on it were people that were interested in primarily in quantum physics and not so much in, like, you know, questions of sociology or diversity, but it's always been open, right? I mean, when I think back to the the HQ conferences, there were always people that talked about that, right? You can say, yeah, okay, they were not sort of in the core of the network, but I don't think there was ever a fear of that, and I think that is a great advantage that we have. That since we're all interested in the same subject, we can afford to be very diverse about our approaches, right? And I think we have been fairly diverse, not optimally. And of course, also I agree that it lags behind sort of the general trend in history of science in a way, but I also don't think that's necessarily such a catastrophe, right? If things don't go quite as fast, I mean, they do happen, right? It's a development. So I think I've always pleaded for maximum openness to methodology, because history has never been like one methodology, right? It should be open, and so of course it would be nice to have like a more steady way of meeting, right? I agree with Olival and with what Jean-Philippe said. Yeah, 10 years is a very long time, and it would be nice if there was a sort of an infrastructure to stabilize that. It is simply dependent on the willingness of people, individuals, to like take on the non-quite simple task of organizing such a thing, and also on the money, right? I mean, that was the advantage we had at the Max Planck, that money was easy, and there was a lot of infrastructure that was there. If you have just a single professorship at a university, it is a much harder thing. So and again, I don't think there's an easy remedy for that, but maybe there could be sort of more of a shared thing, right? I mean, in a way we did that with the conference in Utrecht, right? A lot of the organization we actually did in Berlin. So, Jos and Dennis Dix in Utrecht could sort of, delegate some of that. So, I mean, that might be a possibility, right? That, between several places you sort of share the organization, so it's not quite such an ordeal. And because I totally agree, it would be nice to have this as a more regular thing. Okay.
Yeah. Okay, maybe just a very quick follow-up, really going concrete, very practical on what you were saying about the series of conference. So I'm part, for instance, of there is a series of conference which has been quite important in the foundations of physics, which is called Foundations of Physics, that happens every 2 years, and this was through this conference they constituted a couple of years ago the Philosophy of Physics Society, that has a perpetual steering committee for this series of conference that happens every 2 years. I happen to be part of this steering committee. And basically what they do is at every conference, within the conference there is an assembly of the members, and is at the conference where they decide who takes the toll to organize the next one. So there is kind of a structure that has been organized. And the same is for the Relativistic Quantum Information Society, for instance. They have one way to organize this is to have that we arrange a formal structure with maybe a perpetual or like a rotation of a steering committee who takes care that they find the next local organizers, let's say. And of course, the money is not solved in this way, but at least there is somehow a push of some people who is not just the individual initiative of somebody who says, okay, I'm going to do that. So there is a hat, an umbrella hat.
I would like to comment on Christoph and Flavio's comments. I think it would be very welcome if we can end this conference perhaps with a project at least of how to do the next conferences. I think we should also take into account that many, or at least a few members of the community that are very actively engaged in the community could not attend here. For instance, Alex, but also Michelle Janssen and others. So I think we should take their perspective into account. So perhaps here it wouldn't be the best place for taking any decision in that direction. But I think we should perhaps find a way of if not here, if not until Thursday, but in the near future, online or something like that, to really make plans for the next meetings and gatherings. I think that is something we really should do. So I completely agree.
Thank you very much. I would like to go back to the problem that the international hero of quantum, one thing that also Elise underlined, that the international hero of quantum wasn't born from an historical urgency, but it was a completely different problem that was faced by Europe for the increasing importance of the idea of quantum, as Alexei said, in other areas and so on. So I would like to ask you a comment on the fact that despite all this community have done, we haven't broken the wall between historians and physicists. And I would like to know if it's possible to have, for example, an HQ workshop interacting physicists and historians on this. Because my feeling is every time that I speak with people learning physics is that they don't really understand what we know about the history of quantum and so on. So I would like to know, what do you think about it? I know that there was a very good experiment driven by Berna and Flavio about the interaction between historians and physicists in the history of history for physics. And I think maybe HQ could move in this direction to expand, maybe to invade other fields. I don't know. I was asking a comment on that.
I'm afraid I'll sound pessimistic on that. I mean, it was understandable when physicists were in power and didn't have problem with funding, that they felt that they didn't need history, and they kind of looked down upon this. I was thinking that by the time when physics fell on harder times and needed to work harder for their fundings, that they would value the public image kind of the discipline that historians partly provide, but it didn't happen. It seems like physicists mostly didn't learn that lesson that some other fields of science have learned. At least that was my personal kind of experience with kind of some of the physicists that yeah. So, and that partly reflects, I think, this year when kind of there's different events, some organized by physicists with as Elise said, kind of with almost no representation of kind of historians, and some organized by historians. At least here in Brazil, there is some funding from physicists kind of that is going for that conference. But that is more like an exception rather than the rule.
Yeah, the UK and European foundations is where I've felt like philosophy and practicing physicists in Europe are really bonding. But yeah, the H is a little bit quiet there. But maybe that's something that could change. I don't know.
So I think one thing that it's a distinctive feature of this community. Yeah. Sorry. Yeah. Okay. Sorry. It's an important and distinctive feature of this community is the fact that we have different affiliations. So some of us are in physics or mathematics departments, and others are in history departments. So in our day-to-day life, we have different struggles surviving in those environments. I'm in a mathematics department, so when I speak about mathematics and physics, they are very happy. But when I speak about history, I have some trouble. And I know other people who are like in history departments, and they have like difficulties finding students in the graduate programs and so on that could do more technical research. So that's a characteristic that is impossible to be solved. It's like it's a good feature of our community, like this plurality, but that makes us have different challenges in our day-to-day lives. So what I try to do is to put more history in my research, despite my difficulties in communicating with people from physics and mathematics. And while others have difficulty, like try to put more physics and more mathematics, so this is something that I think it's a very clear aspect of the history of physics in general, but also of the history of quantum mechanics. And in that sense, I believe there is a beautiful article, beautiful book chapter by Olivier d'Arrigol in a book Positioning in the History of Science, edited by Jürgen Hahn. And in that chapter, Olivier d'Arrigol argues that we should keep our contact with historians, but we should also strengthen our contact with physicists and mathematicians. And I think that's inherent it's part of our of our job to be in between those communities, and I like to be there. I think it's a very good place to try to interact, but that imposes on us a few challenges that we have to think how to deal. Yeah, so that's, and I suggest the chapter. It's a beautiful chapter by Olivier d'Arrigol.
I think it's me now. Yeah. I've had a thought or a plea that I wasn't sure whether it was right to bring it now or in the later session. But because we've talked so much and thought so much about the Archive for the History of Quantum Physics, I'll bring it now as a question that you might think of also and develop thoughts about in the next round table. That's to do with the thought that one of the fruits of the Archives for the History of Quantum Physics was also the Niels Bohr archive. And it's in a very unusual situation of being an archive that's physically housed in a physics department, and that has an extraordinary level of curatorial care and relationship. And coming out of the discussion of the AHQP, we've seen a lot of its difficulties. And one of those difficulties is that it hasn't been digitized and it isn't readily available. What I would like the Niels Bohr archive to do is develop the archive of the future, in a sense. I would like the Niels Bohr archive to collect from science in practice. And that's my answer to how we might develop a new version of an archive that can be really useful for physicists and for historians, and maybe even for philosophers. So I'd invite you to give any comments that you have on the thought of what would be really helpful for an archive to do, and others to think about that for the future, and let's keep gathering suggestions on that and see what we can do.
Yeah, it's partly related, especially related to the previous question on the interaction between physicists and historians of physics. So as you were saying, Bernadette and I, we have been trying to do this for last few years, and in particular we have edited this special issue that was, yes, I don't know if it's still on the table outside. The experience was very an eye-opener for myself, because I thought that there was a bit this narrative that maybe you, Alexei, were saying now, that it's the physicists somehow, they're reluctant to have the historians in their life, or they don't appreciate the value of this. And our experience with this special issue was actually the opposite. So we received an amount of applications of physicists pleading to find a partner because they didn't know any historian that would know the history of their field, and we were not able to. So many physicists had to not participate in this effort because of a lack of historians wanting to, or just not existing to interact with physicists. So this is something we should all reflect about, that there are many physicists out there that if you throw a stone, they are interested enough to have this kind of collaboration. So this was very good signal from the part of physicists, and quite bad from the reaction as, I mean, I'm both, but as an historian, I was sad about this, that I was not able to pair them. So, yeah, just sharing this experience.
Yeah, this is related to what Flavia said, but I don't think Richard had ever an answer for his thing, so maybe we should do that first.
No, I just, in response to Richard, I have a somewhat older memory of the struggles of the Niels Bohr archive, because initially it was created for the purpose of publishing collected editions of Niels Bohr works, and once it was done, it wasn't clear whether the archive will continue. So basically, they had they had to struggle for that. But it's so luckily for them, it was resolved, and the kind of archive continues even after the collected work was finished. But even though the archive is still largely under the control of the family, and a large part of the material there classified as Niels Bohr's personal collection, which is not open to the public in a regular sense. So, and that is the difficulty that kind of is still remaining, because kind of, it's harder to make kind of an archive kind of for the future when it's still mostly in the possession of the kind of interested parties.
Well, those of you who are going to be in, which is all of you, just start writing down your thoughts on a given day about the field and dating it clearly, and that will help future historians.
Yeah, so just to give you a little bit, can you hear? Okay, so just to give you a little bit of background on what the American Institute of Physics has been thinking about around IYQ. Of course, we're not central to this community, so we want to be very strategic about what we do. So we kind of have three things that we've wanted to work on. One is this digitization question. We are one of the repositories for HQ-5 ourselves, so of course, you know, we want to think about that, and we have a large library and archive staff ourselves. They're not represented here, so I'll just speak a little bit for them. So that's one element of it, and I think that there, you know, we probably won't be able to accomplish the entire thing, but I think that we can make initial steps, see where the progress can be made. The second thing we want to do is to look at the contemporary history of quantum science, which is, of course, a very active area right now. Elise was alluding to this earlier, and I think that that's a good opportunity to make some headway in talking with the physical sciences community. We want to deploy a qualitative survey to the community to kind of get, it's like a sort of mini oral history where we can collect a lot of information at once and hopefully also stoke some interest. And then the third thing is actually the subject of this panel, which is to do an earnest look at the historiography of quantum mechanics. There have been some good literature reviews. We were thinking maybe taking a historical approach to it. And so that actually gets to my questions, of which I have two, and you don't necessarily need to answer them. One is an intellectual question. The intellectual question is, when we look at especially that early history of the 1960s, to what degree should we think of that as a professionalization story, and to what degree should we think of that as actually of a piece with some of the other histories we tell about this period of Copenhagen and its dissidents, of Dave Kaiser's hippies, and so forth. You know, the Kuhn's project was not originated by Kuhn, it was originated by Wheeler. And what was Wheeler and his friends' motivation? Kuhn was based for an entire year or more at Copenhagen during this period. So it's not separated from that history. It's not the historians coming in to rescue the history from the scientists. The scientists are very much involved, and what was their motivations, and to what degree can we think of people like Foreman as in conversation with these broader things going on. So that's the intellectual question. You probably don't have time to answer that now, but I did want to introduce it. And the second is that when we look at the historiography of quantum mechanics, it's a very privileged one, notwithstanding the various ups and downs it may experience. It is, I think it qualifies as one of the industries in the history of science, along with the Einstein industry, the Darwin industry, the Newton industry, and so forth. It's probably one of the only ones that's not around a single personality even. And so to what degree can we take lessons from that? You know, to what degree has it functioned efficiently as an industry? To what degree has the historiography been coordinated, if not necessarily organized? And to what degree can we take lessons of that from other areas? I'm thinking specifically of the historiography of particle physics, which itself in the 1980s may have made claim to being an industry, but I think is deindustrialized in the interim. And now, we're looking at, there's going to be a major symposium at CERN in November, and that's going to be dominated by scientists with just a few historians there. And so maybe that's an opportunity to see how we can work with the physical scientists, but also, how can we bring the approach of having an entire community to try and revivify something like that historiography. So those are just some kind of random thoughts, probably too many to respond to, but I wanted to get them in.
I think part of the answer to the first one, I can't say anything about the second, at least in the case of two of my academic forefathers, Abner Shimoni and Ernie McMullen, like they were in physics departments and did not find there the space that allowed them to ask the questions they were curious about. And so they sort of forged this new space, and it eventually became its own. That's the sound of professionalization. Do any of you want to try to answer the second question? Or? Oh, there's more. Okay.
Okay, you can hear me. It's such an exciting conversation to hear and learn from, and I wanted to respond to the general question that Richard raised and also Will about where to go from here. There's been so much conversation about the original archive, and at the end of the day, these all come down to questions about funding and questions about priority and questions about culture. There's been a rich conversation both in our group, but it sounds like also even more so with the early career scholars in talking about inclusive practices. There was a question from the corner of the room about how do we bring these stories forward? Why do people have fear? Elise gave a beautiful answer saying this is not about fear, it's about the difficulty of recovering this history because women, because scientists of color historically do not preserve their records in the same extensive and careful way, and institutions do not preserve those records in the same historically dedicated and inclusive way. This conversation about HQ-5 begins to shine a light on the challenges that the community as a whole faces when we try to broaden the conversation about who has been here all along. And with that in mind, I want to seize this opportunity to respond to the questions from all sides of this room to remind ourselves that we need to commit to supporting the creation and the construction of that history, not exclusively to turn back to the question, although it is an important and valuable one, of how do we resuscitate lost documents, documents we know we used to know how to find, but also how do we put resources and energy and commitment into the collection of a broader set of materials from a broader set of contributors. I see this thread running through all of the conversations that everybody has added to the discussion this morning, and it's really energizing and thrilling and inspiring, and I know that AIP has already taken impressive steps to expand the support for the collection of those materials. But as we discuss these topics, I think it's really important to reinforce how incredibly valuable it is to put our energy, our money, our support behind those collections. In response to Indianara's question, why are people fearful? I agree, there's this mix of considerations. There's maybe some fear, there's also respect, that was commented from the front of the room to not pretend to something other than you are. But as someone who's been researching an underreported physicist, and this is even a physicist who's well known, but where the records are thin, I think the historical challenges that the old guard has commented upon in resuscitating the old materials from the original archive, from the Kun times, those challenges really resonate with the experiences of trying to research a woman, research a person of color who may not have seen themselves as worthy of preserving their own records. So we need an institutional voice that says we are committed to finding, inviting, preserving and protecting those records so that they are there for the future. I've said it 3 times, and I'll hand the microphone over to somebody else.
Hello. So the archival conversation is pretty interesting to me. I think there's a lot of different thoughts we can have about the archive. But on one side, I do think it is important to try to find collections and add them to the archive, but at the same time, I'm not sure if some of those collections should be added to our archive, because I think that they're already in other archives, so I think that's can be problematic in some ways. So I think we just have to look to the humanities a little bit more and start to question the creation of our field and the constructions of archival methods that we're holding nigh to, because our field was created by, scientists, and they're applying scientific empiricism to the humanities, whereas we actually need to start thinking about applying humanities to the history of science. And you have examples already out there, like Britt Russert wrote a book called Fugitive Science and is talking about the constructions of scientific empiricism even in literacy. You have Ruha Benjamin is also a good example. They're outside of our fields, but they are doing work that contributes to the history of science. So I think thinking about how we can lean more into humanistic methods and then not being afraid to use multiple archives. I think that's perfectly fine from my perspective, because and simultaneously also trying to get some of those collections, but it would depend on if those communities want to have their collection added to that archive. That's one part of it. But then also, there's also archival power, like different levels of power within archives. So I think there's a lot of things to think about, but I think we shouldn't be afraid to do that, because if we continue to be fearful, then our stories continue to be the same.
Just one word about the limitations of the archive. So indeed, the archive of quantum physics is vast, but also limited. And much of what we're doing now is not from sources that are in this archive. So it's okay to digitize it, but it will not solve the problem, because we're now going to to different sources, to different archives, which are not included in that one.
Okay. On that note, I'm afraid we need to conclude this roundtable. That's been incredibly interesting and lively and productive, and I hope the conversation will continue. Thank you all. Thank you very much to our wonderful panelists. Thank you to the audience. And okay, let's go for a break now. Oh, okay. I have a little announcement, a little self-promoting announcement to make. On the table outside, there are flyers that can give you a 30% discount on the purchase of our book on women in the history of quantum physics. So please do take them.
Hello everyone, welcome back after coffee break. I hope you enjoy it. So let's start our 30 keynote lecture. So it's a great honor to welcome Professor Danian Hu, a distinguished historian of modern science and technology, both in the West and in China. His recent works focus on case studies of selected scientific disciplines, institutions, and individuals. So Professor Wu, Huan Yingning.
Thank you very much. Portuguese. Thank you. Okay, so I have lots to cover, so I have to run fast. You see the title of my talk. Oh, sorry. Thank you. It's the title of my talk, the quantum, China's quantum journey, which is covered nearly 100 years. Let me begin by saying that China, over the last 2 or 3 decades, that the Chinese physics has made quite a few groundbreaking contributions to quantum physics across diverse fields, especially quantum information science, astrophysics, condensed matter physics, and neutrino research. For example, here it's reported Physics Today, I think Science, it's the MISHIS satellite China launched to test the quantum information. And the FAST stands for 500-meter aperture spherical radio telescope, which is looks like this in the southwestern part of China. It's a catalog pulsars, probe gravitational waves, those kind of things. Listen to transmission for the alien civilization. In condensed matter, we have the Chinese, recently a Chinese physicist who actually is the president of my current university, Professor Xue, who won this is the first Chinese won the Oliver Buckley condensed matter physics in 2024. In the neutrino experiment, neutrino physics, China made unique contributions. This is an internationally joined project, I believe, between 2011 2020. This is the Daya Bay reactor neutrino experiment, but this was the experiment looks like. And there's currently the new one, probably is already start to collecting the data right now while I'm speaking. It's open, expected to open officially, collect start the data collection this month. It's called, in short, it's called a Juno. It's a Jiangmen, what's a Jiangmen? Anyway, the acronym here's a Juno. This may answer a long-standing neutrino mystery. There's a few more pictures about this Juno experiments. Okay, you can see in the details the report of the Science magazine. Well, China's journey of quantum physics. So my title, the title of my talk, all of the previous mentioned remarkable Chinese achievements stem from China's century-long commitment to advancing modern physics in the entire 20th century. Actually, the Chinese journey has been unfolded in tandem with the development of quantum physics itself in the 20th century. Literally, this is the very first college physics textbooks in Chinese was published in 1900. That's the beginning of the quantum, the concept. So it was translated from the Japanese original, and was a Japanese original textbook, and translated by a Japanese scholar, sinologist, and a Chinese scholar, a traditional Chinese scholar, Wang Jilie. Interesting things is that this three character that's still in use in China stands for the English term physics, and that the term starts the beginning to use starting in 1900. So in terms of the terminology or glossary of modern physics, the first Chinese, the official vocabulary or glossary of physics was published in 1908, and from this we learned that almost more than 2/3 of the Chinese physics terms were directly adopted from the Japanese counterparts when the Japanese using the kanji, that's the Chinese character. And so, for example, inside of this glossary, that's English. This on the left column is English, in the middle is the Chinese, and on the right is the Japanese. So whenever the Chinese and the Japanese, the terms are identical, they just omitted one of them. Okay, so this is the physics and the Chinese term. That means the Japanese is identical. The very first Chinese, so far we know, Chinese PhD in physics was born in Germany in 1907 in University of Bonn, whose dissertation challenged the Lenard's argument who was 2 years ago. Lenard just won 2 years before. Lenard just won the Nobel Prize, and his supervisor. This is Professor. Whoops, what's going on? This is Dr. Li. Dr. Li. The supervisor was Heinrich Kaiser. Now we talk about the two Chinese pioneers, about two Chinese pioneers of modern physics, Mr. Xia and Mr. He. Xia received his college education at Yale University in the States, in the United States, and then he immediately after graduation from Yale, he immediately went to Berlin, and he took courses from 1908 at the University of Berlin. He took courses with Max Planck, Rubens, and others. But it's not clear whether he, according to the courses that he take from the archive, we know that he took Planck's courses on heat. And several other courses, but not specifically on the quantum physics. So it's not clear whether he learned from Planck's lectures on the energy quanta. But judging by the time period, because in 1909, Planck visited the United States and gave a series of lectures at Columbia University. In that lecture series, Planck specifically talked about his energy quanta. So in this time period, Xia should have learned about energy quanta, but we have no evidence he wrote about it in Chinese. So he was not the first Chinese physicist to introduce quantum, or for that case, in the special theory of relativity in China. Xia went back to China, became the dean of School of Science at the Peking University. And let's say the other Chinese pioneers, Mr. He, who studied with Arthur Schuster at Manchester University, and when he graduated from University of Manchester, Rutherford was recruited by the university, and he must have heard Rutherford lectures, but
It is on the history, Chinese history record shows that at Peking University, where both Xia and He taught in this period, in as early as 19 theory of quantum, but it's not clear who taught that course. So these two Western-educated Chinese pioneer we don't know whether they we don't have evidence that showing that they first introduced the quantum concept in China, but we do have solid evidence that it was the Japanese-educated Chinese physicists who introduced seriously the quantum physics in China. And this one was another physicist. He was trained as a philosopher and educator. But he was the very first one who mentioned the term quantum theory in one of his essays in a philosophical debate with the president of Peking University. The interesting thing about his essay was that this is the very first appearance of in Chinese of the term quantum theory, and judging by the Chinese character here, this is the concept. This term vocabulary was also adopted from the Japanese counterparts, and that also shows the Japanese heavy Japanese influence at the very beginning of the 20th century, because in the first 10 years of the 20th century, all the scientific textbooks were translated from Japanese. Both the Xu's introduction, however, is very superficial, and he did not bother to elaborate. This is, nevertheless, this is the substantial introduction of quantum theory have to wait until 1920. And by another Japanese-educated scholar who was a physicist by training, Zhou Changshou, and his Japanese professor was Nakamura Seiji, an experimentalist. So Zhou introduced many perspectives of the quantum physics, outstanding, including quantum theory, the theory of relativity, radioactivity, and the structure of the atom. Over about a decade, he published 18 papers and 2 books. Let's begin by talking about his introduction on quantum. For the quantum, over about 6 months, he published 3 important papers. And his first one was on the light waves inducing electricity. Basically, it was introducing the photoelectric phenomenon. But his main purpose, was to introduce the quantum theory, and he listed all 4 different the interpretation of a photoelectric phenomenon, but he favored the last 2, Einstein's quantum theory, meaning light quanta, we know, and the Richardson's statistic interpretation of that phenomenon. And he also, in this essay, he introduced the Bohr's theory and applied it to the quantum photoelectric effect. And the second paper was interesting because this is the very first Chinese translation of Planck's paper presented at the first Solvay conference. The choice of this translation was important. And this is a wonderful choice because the author, Max Planck, was the inventor of quantum, and because the Solvay conference in 1911, the first one, is actually the very important milestone in the history of quantum physics, because only after that the quantum physics this concept and its theoretical development spread outside beyond the German-speaking Europe. And the third paper by Zhou Changshou was a synopsis of the quantum theory. In this essay, he summarized many of the perspective of the quantum physics up to then he had learned from all kinds of literatures, including thermodynamics and probability, radiation laws, energy quanta, elementary quantities of actions, and Planck's new theory, and so on and so forth. In Zhou's, in this essay, summarized, he concluded that he introduced the quantum theory of Planck-Einstein school. Okay, but he said that he has not explored another school, for example, by the school of Sommerfeld. Sommerfeld's theory is, according to Zhou, is greatly different from the theory above, meaning Einstein and Planck's school, according to the Solvay report. There's also, he pointed out that there's many other theories, each had its own merits and cannot be totally denied. So that's Zhou's understanding at that time. He was uncertain what exact form the quantum theory would take in the future. But he was confident and optimistic that quantum theory has a boundless future. And then he ends his essay by quoting Bragg, saying, Planck's hypothesis is not so much an attempt to explain as a focusing of all the difficulties into one, so that if this master difficulty is overcome, a number of others melted away. So, well, the Japanese trained scholars played an important role in introducing quantum theory, quantum concept into China. But in terms of the physics research and in the original research work has to wait until the Western trained physicists return to China. Okay. And here showing you 4 Chinese pioneers in original physics research. All of them were trained in the United States. You can see in the chronicle order, and this Hu Gangfu, who was trained at Harvard, and later who trained this Wu was Hu's student, and Rao Yutai, and this one who's a student, including the Dayou Wu, that's later we'll see Dayou Wu's other outstanding accomplishment, and Ye Qisun. So all these 4, you can see Hu Gangfu was a dissertation on the X-ray, and Rao Yutai's dissertation supervised by K.T. Compton. And Wu's supervisor was A.H. Compton on Compton effect. And Ye's supervisor was Bridgman. So that's all the 4 previously mentioned Chinese pioneers in physics research were experimentalists. And the first 2 Chinese theorists also emerged in the United States. But that was a little later, in 1928. In 1929 was the beginning, can be said, the beginning of the theoretical physics study in China, because in this year, all 3 physicists listed here, S.C. Wang and P.Y. Cho and William Band, start to teach, start their university teaching position in China. Actually, almost all of them, eventually all 3 of them teaching in Beijing or Peking at the time. And here's we come to the picture showing the S.C. Wang, showing here, who was regarded as the sole Chinese participant in the quantum jubilee in the late 1920s. So allow me to say a few more words about S.C. Wang. In 1928, in the United States, the domestically U.S. university produced dissertation dealing directly on quantum physics. There were 5 dissertations. Okay, Wang's dissertation was among them. But among these 5, only Wang's dissertation have no supervisor. Because at the time, the Columbia University Physics Department, there was no professor was qualified to supervise the quantum mechanics research. Nevertheless, he was awarded the PhD degree, and later was published. And Wang was educated in the United States first at Cornell University for 1 year, and then got his first master's degree. And then at Harvard, spent another year, received his second master's degree. And but then he decided in 1926 to transfer to Columbia University. I'm always curious why did he do that when the Columbia University did not have anyone to guide him. He took 12 courses at Harvard University, but no single course was directly on the quantum mechanics. So they were not, Wang and his cohort in these pictures were not formally educated in quantum mechanics in the classroom, but they actually taught themselves. Okay. And so they formed, because I. Rabi formed this group. They called, at the Columbia, a number of graduate students formed a weekly discussion group that we called the Sunday Soviet, because they always meet on Sunday. And by which I mean that we met every Sunday near 11 o'clock in the morning, and then went on right through a Chinese dinner. And we learned a great deal just by ourselves. And the biographer of Rabi, John Rigdon, wrote that their Sunday physics seminar would at some point adjourn to a Chinese restaurant, and where S.C. Wang would do the ordering. After eating, then they would continue their discussion into the late evening. So let me see a few more words. Maybe you can see that's Rabi, and this is Koenig, the first physicist who actually discovered the electron spin, but did not publish because Pauli's criticism. And all the others, so among these 5, all 4 of them received a prestigious postdoc fellowship later on. So Wang's dissertation also was unique. He independently developed a method for solving Schrödinger's equation for hydrogen molecule, and using the, I think later on especially, he was, let's skip this one, his postdoc paper, he did his postdoc study with Van Vleck at the University of Wisconsin-Madison, and this one he using the matrix, which is matrix method, matrix quantum mechanics, to solve this complicated problem, non-symmetric rotation of polyatomic molecules. Okay, and he built up his this energy level formula, which was used for decades by physicists. Now, Wang returned to China in 1929. As we said, all three the theorists start to teach in China, teach theoretical physics in 1929. But he stayed in Hangzhou in Zhejiang for 2 years or so, and then he moved to Beijing. But unfortunately, Wang, because of the threat of Japanese invasion, he quit the physics research and moved on to the government and focusing on building China's heavy industry. And he became the founding father of the modern Chinese machine industry later on. Wang maintained his lifelong friendship with I. Rabi. Another second theorist was Zhou Peiyuan, who was a theorist that was a graduate from Caltech, focusing on his research on the general theory of relativity. He attended college at the Tsinghua School, and then he moved on to, in the same year, 1924, in the same year, in 1924, both Wang and Zhou went to United States to study. Wang went directly to the graduate school of Cornell University. Zhou had to start as normal and start from the junior class at the college, undergraduate. So at Chicago, you can see in the round circle, this is P.Y. Cho. And in the front row, you can see Michelson and Gale and Compton, A.H. Compton. And there's two other Chinese physicists. This Will Xun, the WOO, the Will Xun, we saw the four experimental pioneers in China. And another, this Y.M. Xie Yuming. Now, Zhou received his PhD at Caltech. He completed his bachelor's degree and master's degree and the PhD degrees within 2 and 3.5 years. So although he came to the United States, started from the junior class, but he earned his PhD exactly in the same year, in 1928, with S.C. Wang. The P.Y. Zhou started after his receiving his doctor's degree. He did his postdoc study in Europe, first with Heisenberg in Leipzig, and then he visited Copenhagen, met Niels Bohr. And because Heisenberg has to, in 1929, in spring 1929, he was invited to give a lecture tour in the United States, in Chicago. So Heisenberg recommended Zhou to study with his friends, Pauli, in Zurich. So Zhou returned to China in 1929, became the youngest professor at the Tsinghua University, and he lectured on quantum mechanics, and mostly his most well-known courses were on relativity. He was the most well-known expert in China in the series of relativity. And Zhou later, in 1936-37, he spent a year at the IAS, Institute for Advanced Studies, and working with Einstein and Infield on the cosmology and general theory of relativity. And then after he left Princeton, returned to China, the full-scale Japanese invasion began, exactly on the very day he arrived home in Beijing. That's July 7th, 1937. That's so-called, in the West, the so-called Marco Polo Bridge incident. And so he immediately helped the Tsinghua University help other faculties and their families to move to South So the university from Beijing moved all the way first to the central China, Changsha, and then eventually moved to the Kunming, southwest, where both T.D. Li and Xian Yang were educated during the war. Okay. And also because of the Japanese invasion. Zhou, similar to like S.C. Wang, he quit his original research in theoretical physics directions. He moved from the general theory and cosmology, general theory of relativity to turbulence. See, he saw the turbulence maybe closer to the national defense related industries. But in China, nobody could use his specialty. Eventually, he came to the United States and served for the Navy, U.S. Navy. P.Y. Chou's distinguished students, including the Wang Zhuxi. That's Wang Zhuxi. Wang Zhuxi was the Xian Yang's master thesis supervisor. Okay, and H.W. Peng Huanwu. We'll talk more about Peng later. And that's all P.Y. Chou's student and their students. Zhou Guangzhao also stand in the West, as Casey Chao. And Ning Hu, okay. The third theorist that we're talking about was from England, who graduated from Liverpool, and how much time is doing? Okay. So his master's thesis was examined by an outside examiner of Arthur Eddington, and Eddington praised his master's thesis. Was only a little bit shorter than the PhD thesis in Cambridge University. That's a high remark, I think. And he moved to China to teach at the American-founded Mission University, Yanjing University, in 1929. It took him more than 5 weeks on the sea to eventually reach China. And you can hear this first department of physics head, the chair of the physics department at Yanjing University. The third one was the Chinese we saw earlier, Yu Mingxie, who graduated from University of Chicago. And Xie hired William Band. And at the Yanjing University, William Band supervised almost 3/4 of all the graduate students' thesis. Okay, 74%. And Yanjing University was also famous for as a educator, leading physics educator for women, and because all the national public university like Peking University and Tsinghua University did not accept a female student in the physics department until late 1930s, early 1930s. But Yanjing University had their first female master's degree. Not the undergraduate was started in 1930, but by 1932, Yanjing already have the graduate student, master's degree graduate from Yanjing University. Two of them, the Yanjing graduates, female graduates, later on went to study in the United States, and both of them end up in the University of Michigan. And they studied with the Dutch American, the Uhlenbeck, Goldschmidt, and so this one, M.C. Wang, was the younger sister of S.C. Wang, we talked about earlier. And in America, before 1949, the 5 top
university, U.S. university, who trained the most numbers of the Chinese physics PhDs were these 5 institutions. Michigan was on the top, and Michigan, Chicago. And in Michigan, before 1949, there was about 12 Chinese PhD in physics graduated. 8 of them were female. And all of them were supported by Barber Scholarship. And this Barber Scholarship is some of the rich businessmen who donate the money to the university and sponsor the Oriental women to be educated in the United States. And by Oriental, they say from Turkey to Japan, the cover. And this is in the year 42, 43, the Barber scholars, and one of them were the C.S. Wang Zhang, the second lady I mentioned in the previous slide. Another two more Chinese theorists were Xinpei So, who was a wandering physicist because his undergraduate student undergraduate education was unique because he spent 4 years in 5 colleges and eventually got 2 master's degrees without a PhD before he returned to China. He studied, for graduate study, he studied with Whittaker and C.C. Darwin in Edinburgh and University of Cambridge. And eventually he got a second master with the Dutch mathematician, the Dirk Stoik at MIT. And So's greatest discovery, scientific discovery, was probably T.D. Lee. He discovered the young, talented student, T.D. And 30 years later, in the 1970s, Lee wrote to So that my fundamental knowledge in physics was acquired during the year at the Zhejiang University. All my subsequent achievements can be attributed to what I have learned from my mentor, you. Okay. And here's another Chinese theorist who was a graduate, one of the 12 Chinese physics PhDs, graduate from University of Michigan, and who was a student, Goldschmidt. And Wu in China studied with this one, one of the 4 experimental pioneers. And Wu mentored both Xian Yang and T.D. Lee. And Wu's other distinguished students, including S.T. Mar and Kun Huang and Guangya Zhu. Now, the European had also exchanges with China during the 1930s. Or late 1920s, Heisenberg passed by China in 1929. This is a picture in Japan, not in China. I can't find a Heisenberg picture in China. But it was on the same trip, Heisenberg passing by Shanghai. He did not go to visit any Chinese institutions, just in passing by Shanghai. And the 1929, Dirac went from he left Japan, went directly to Soviet Union, did not visit China. But in 1935, he did came to China, spent weeks visiting and give lectures in Beijing. Here's a picture shows he was meeting with his Chinese colleagues and visiting the Forbidden City in Beijing. And Zhu Shiwang, who was one of the P.Y. Chou's favorite student, accompanied Dirac visiting the Great Wall. Okay. And Zhu Shiwang wanted to study with Dirac as a graduate student, but Dirac
declined and recommended him to study with Fowler, and he earned his PhD at Cambridge with Fowler. Bohr, also Niels Bohr, his wife and one of their sons, and also visited China in 1937. And here's some picture visiting Great Wall and the Forbidden City. And all these theoretical Western physics masters came into China, gave a big push for the development of physics in China. But there were many promising developments in the late or mid-1930s, but the hopes quickly and other plans dashed because of the Japanese invasion in 1937. So for example, SC1, both SC1 and PYHO quit their original research directions, this inevitably slowed down the Chinese development. In the 1930s, there were at least 2 or 3 distinguished Chinese experimental contributions. One of them was Chongyao Zhao, who actually first captured the positively charged electron. This predicted by 5. All right, I'm sorry. Okay, so and another experiment was the Y.M. Xie, who did complete some very significant experiment born directly on the worth of quantum field theory in general and the renormalizability of the quantum electrodynamics in particular. Okay, so others, there's a student of Casey Wang who studied with, that's Casey Wang, studied with Lisa Meitner, earned his PhD in Berlin. This must be the Hahn. Okay. So Casey Wang proposed in 1941. He wrote a short paper, proposed the use of a K electron to capture to detect the neutrino, and which eventually his suggestion was followed by American physicists and eventually confirmed the existence of the neutrino and eventually identified. The other students of PYHO, including this Huang Wupeng. Okay, so this here shows that's a Peng and with Max Born, Schrödinger. He earned 2 doctor's degree under Max Born, and then did his postdoc with at Diaz with Schrödinger. That's Heitler. I think this is Elwood. Okay, so this is at the Diaz, the symposium, 1947. There are 2 other Chinese physicists, Ning Hu and Casey Chen Kaijia. So, about the CS Wu, in the late 1940s, the contribution was now we recognize. For the details, we have to wait until the Dr. Frank's talk tomorrow. But Wu in 1949, and his Wu and his graduate student conduct a photon measurement experiment to verify the theoretically predicted angular correlation and entangled gamma rays photon. And this is now recognized by many as the very first experimental evidence of the quantum entanglement. Wu also had at least 12 Nobel nominations, but she passed away without any of the honor of such a. So in the late 1940s, China collapsed in the Soviet Union. Dubnar, Casey Wang once again made some unique contributions by discovering this a new particle, the anti-sigma hyperon, the first hyperon of its kind. And another Chinese scientist, Casey Chou, also made theoretical contributions during at Dubnar, in Dubnar. And in terms of the genealogy of the Chinese theorist, you can see Zhou and his student Peng, and Peng's student of Casey Chou, and Zhou's student of Professor Wu. Wu's students was we know that Danian Liu is here. Okay. Now, in the mid-1960s, China's physicist was their own unique model following Mao's philosophical thought, and the Chinese model assumes the interaction of a hadron. Hadron can be explained. In the model, they named straton. Okay. And this was not widely recognized by the international committee, but it has trained a large group of young Chinese physicists as a result. Okay, Danian Liu had a monograph studying on this case, and she had this a series of conclusions, which I don't have time to detailize this in the 1960s. In the reform year period in 1978, 2008, the China government, because after the suffering the 10 years turmoil period in the Cultural Revolution, Chinese government adopting the new policy to mobilize the Chinese scientists, and the Chinese government scientific community reintegrated with the international scientific community. For example, in 1984, China rejoined the IUPAP, and also the government gradually increasing the investment in scientific R&D and constructing large-scale the infrastructure in scientific research, such as Beijing Electron-Positron Collider. And Chinese government also actively recruit the talented Chinese scientists, physicists studying overseas, and especially after the mid-1990s. So with the last few three slides here, so we talked about the FAST. The chief architect was also trained overseas and then returned to China in the mid-1990s. And Yifang Wang, who is the chief architect of the both Daya Bay and Juno experiment project, was also trained in the West. And this one, Qikun Xue, who was also returned to China around at the beginning of this century. And all of them leads to the China's current the remarkable development in quantum physics. Okay. Thank you.
Professor Hu Feicheng Genche, thank you very much. Yeah, so we have time for questions and comments. Sure, yeah.
Thank you very much for your wonderful talk. I would like to know if there is there any archive in China where we can find documents from the visits from both Bohr and you said Dirac, right? When they went to China, and maybe other physicists.
That's a good question. That's one of the biggest challenges doing history research in China. We don't have, it's not easy to find the relevant archive materials, partly because of the for decades, China was in the foreign invasions, civil wars, and the political turmoil. So that destroyed much. And secondly, the archival system was not well built in a sense. And there's also have difficulty. I think Dr. Frank probably had the personal experience. It's often frustrated to visit the archive. Also, sometimes you know the archive material is there, but it's not open to the researchers. For various reasons, maybe you have to be very patient to do the research. By finding the secondary materials, or interview the eyewitnesses, some of the relatives of the senior scientists who happened passed away or something, and collect from their personal collections. The archival situation, I think, is getting better. It's improving, but it need no. It just take time. You have to try and error. Find your own, build up your own experience to do that. Okay, thank you for your question. Yeah.
Okay. Thank you for this wonderful, rich presentation. Consider the cases that some students went abroad, went to some Chinese student in US or Europe. I'd like to know a little bit more about the founding process and the policies involved in this process, because it was for general subjects or they had to go to study something specific topic. Because you mentioned that in a certain moment, I think that the four first students, they were all being trained in experimental physics. And for example, in this case, it was their choice or they had to do it?
No doubt it was their choice, and actually it's very competitive to win the slot, sort of, and to be entitled to be sent by the government funding, and to most of them, or I shouldn't say most of them, a lot of top Chinese scientists went to study overseas, were sponsored by the state government or the local government, provincial governments, but there's also part of the, as we say, the Barber Scholarship, which are the private foundations, and Rockefeller Foundation also played a key role in sponsoring Chinese physicists like Y.M. Xie, who studied in the United States, was sponsored by Rockefeller Rockefeller Foundations. There's also the so-called Boxer Indemnity Fellowship, which is the Chinese payment to the United States because of the Boxer uprising, the damage on the U.S. properties in China or personnel. But the U.S. government actually, on purpose, charged more than double of the actual cost, and it end up they have a surplus, huge surplus, and they cannot hide, so they have to return it. And they starting from 1908, they passed the bill in Congress, and eventually they start in 1909. They refunded this more than, I think, more than 10 million US dollars at the time. And they founded the Tsinghua University using part of that fund. And then each year they sponsor the Chinese student to study in the United States. They hope that those Chinese students, only a small portion of them study science and study physics. They certainly the U.S. government on the U.S. government's point of view, this returned Chinese will tend to be favor the U.S. politics and business and later on. So they have other concern. But most of the, we have to say that the most Boxer indemnity fellows, the Chinese who educated in the United States, later on played a major role in the 20th century development in science and technology in China. Okay.
Yeah, thank you for your wonderful presentation. Was especially fascinated by the earlier slides on the introduction of the conceptualization of physics and quantum physics in China, and especially that it was done not necessarily by a physicist but by a philosopher. And I wondered how this maybe changed or shaped the way the specific quantum theories were received in China, and then specifically also if it mattered that this at first went through Japan. So was there a specific Japanese interpretation that was introduced in China first?
That's a very good question. I don't have a full answer for that, but I don't think the first introducer who was trained in philosophy and education, higher education in Japan, who later played any active role in terms of the dissemination of the quantum theory or interpretation of quantum physics, who just using the modern science as a tool for his philosophical argument, because that was during the so-called China's Renaissance in the 20th century, the May 4th movement, the intellectual revolution in 20th century China, the May 4th movement, which is named by because of the May 4th protest in Tiananmen Square, because of the Versailles, the 1919 peace agreement in Paris, in Versailles, then gave the Germany to occupy the Qingdao and the Shandong Peninsula, and that instead of returning to China, China was on the victory side, but instead of returning the German occupied territory to China, they gave that territory to Japan. And when the news came, the college students in Beijing went to the Tiananmen Square to protest on the May 4th. And that was the name of this period. But the cultural movement or the intellectual revolution period of May 4th movement lasted from 1917 to 1921 or 23. And that was a period all the Chinese intellectuals, including the philosophers and the scientists, they were mobilized. They were mobilized to learn from the actively try to learn from the West. They have two banners, so-called. The Mr. De was the democracy, Mr. Democracy, and the Mr. Science. That was their two major goals during the May 4th movement. Okay, so science was a big part of this cultural movement, and any Western ideas were welcomed, and Western scholars like Bertrand Russell, Madame Curie, Albert Einstein, they were all invited. And in the United States, John Dewey spent years, 3 years in China. So most Western ideas were introduced into China via Japan, because Japan was more active in learning from the West earlier than China. In terms of physics development, at the turn of the 20th century, Japan was probably about 30 years ahead of China, because China was closed for a long time, especially during the late 19th century, the so-called the century of humiliation. Okay, I'm not sure.
Yeah, thanks for your talk. I would like to know if you could comment more about the influence of Maoist philosophy on quantum mechanics in China, and if before, in the early 20s, any attempt were made to approximate the quantum mechanics of the previously Chinese philosophy.
This I haven't do the full study on this subject, which is an interesting subject, and intend to look into it. But in terms of the philosophical impact directly on the quantum physics research, I think Danian would be it's an expert. You can ask her. She published a book on the especially the Stratton model and other construct. In general, this is it's similar to the early period in the Stalin period, the dialectical materialism and so the Chinese physicists in the mid 1960s working hard on building their own quark, so-called quark. In the West, we have quark, everybody knows. But in China, they try to build their own model. It's a Stratton. So because Mao's philosophical idea was all the matters can be divided endlessly. You can always divide into a smaller. So they have different layers, okay, different layers, the smaller layer. So even when T.D. Lee and C.N. Yang met Mao in person, Mao was asking them these similar questions about this. So it was based on Mao's idea, following Mao's philosophical idea as a guide. A large group of Chinese mathematicians and physicists, especially young people, joined. They had a joint effort, working for years to they completed this paper and published. It was not published internationally, is it? In Chinese, mostly in Chinese. So it was not widely known. But some American, Western physicists praised this highly or positively in the sense. For example, who was that? The Sheridan from Harvard? Salam, that's Pakistan. And the American, Glacial, yeah, who even coined the particles. He wants his Mao particles, the Maoans. So those kind of things. All right? Yeah. I'm not sure I answered your question.
Thank you for the wonderful talk. It's a little bit different comment, different from these hot topics of quantum mechanics. But I want to add to our conversation that in which concerns the interactions between Chinese physicists and Brazilian physicists, we had in the past, and we also still have a very important collaboration. We can say that China and Brazil, they both learned together how to build satellites. And I'm talking this because this began in 1980, which was still the time of the military dictatorship in Brazil. And Brazil set diplomatic relations with China before the end of the military dictatorship. And as the military dictatorship, as part of the Cold War, was aligned against the Soviet bloc, it's interesting to see that it's my conclusion, the diplomatic and geopolitical interest between China and Brazil predates the current rapprochement between the two countries. And more recently, we are building, through a collaboration with China and the researchers from the University of São Paulo and the São José dos Campos, an observatory, radio wave observatory for cosmological researchers in your state, in Paraíba, which is at the northeastern part of the country. So it's just an addition, and thank you very much for the wonderful talk.
Oh, thank you. I learned a lot from your question. Yeah. Alexei. Don't ask too hard questions.
Yeah, no, not very hard. But I was struck by the term Sunday Soviet in this RABI meeting. I wonder what year was that meeting, because the term was also not commonly, but used for one important project in Britain. And it meant, this hybrid term meant actually a collaboration between very left-wing pro-communist scientists, physicists, and very right-wing anti-communist military in late 1930s, when the two groups were collaborating on creating radar and radio location and radio defense for Britain. And so they use this term hybrid because Soviet meant something very left-wing, Sunday meant something very right, or at least religious Sunday service. And that's how they meant it at the time. But that was probably later, because I don't know when and I didn't think of RABI as being particularly left-wing either, so that was something I kind of didn't quite understand.
That's a very interesting comment. Actually, yeah, I was wondering why they coined their group as a Soviet. Yeah, I don't know the reason. This must be because SC Wang moved to moved to New York in 1926, and he graduated in 1928. So it must be between these 2 years. Okay.
Tiago, would you like to know? Okay, Professor Hu, Fei Chen Ganche. Yeah, thank you.